All right, so I just gave you guys like a million sheets, okay? And as I've mentioned many times in the past, I tend to try and give you guys more practice than I think you actually need, but that way you can practice as much as you want, okay? And if you're watching this video from home, all those sheets are attached below this video. Let's go ahead and go through the concept map. I'm going to fly through this. I don't want to spend that much time on a concept map. But here's like a way to visualize all the stuff that we learned. So we have a whole lot of history. It started with Democritus. Okay, he was that Greek guy who first came up with the idea of atoms. Didn't do any science, no evidence, no model, nothing like that. He just came up with the idea that atoms build up all the stuff in our universe. Lavoisier, first guy, did some science. French did law of conservation of mass equals before and after. And then his wife wrote it all down in a way that people could actually understand because his notes were like a hot mess. But then, the French Revolution happened. He got his head cut off. Good times. Proust, our water's better than your water, blah, blah, blah. Turns out everybody's water is 2 H's, 1 O. A lot of different proportions. Dalton tied a lot of that stuff together with his atomic theory. And he was the very first one with a model, that's right. And it was the marble. How do I draw his marble model? Just by going like that. Okay, just draw a little circle. All good. Then Thomson discovered the electron, so now we got this positive blob with the negative sprinkles on it. He called it plum pudding. Rutherford, which was a big hitter here, he did a lot. So he did the gold foil experiments. Not only that, he found the nucleus. Okay, so that's a part of the atom that he found. Not only did he find a nucleus, but he learned 3 things about the nucleus. That it was dense, that it was small, and that it was positively charged. And on top of that, he learned that the atom is mostly empty space. That's what I'm looking for, yeah. So there's a lot of information to know about Rutherford in terms of like the points of information that he learned about the atom. He probably has more to remember than anybody else. Right after him was Bohr. He thought that electrons orbit the nucleus on predictable little paths, like the planets orbit the sun. That's not exactly how they work, but he did learn a few things that we still find true today. When something's low energy close to the nucleus, what do we call that? Ground state. That's right. And when it's high energy far away from the nucleus, we call that excited state. You got it. And old James Chadwick, aka Jimmy Neutron, discovered that neutron. Good times. Now, other things you don't want to forget. Okay, you want to remember that the Z, the atomic number, and the number of protons are literally the same thing, okay? It's not like, oh yeah, they're used, lots of times will end up being the same number depending on the problem. Like, no! The Z, the atomic number, the number of protons are literally the same thing, okay? You can use all 3 of those interchangeably. Now, the mass is at capital A lots of times. And your protons plus your neutrons. If you want to find the neutrons, you'll find a difference between your mass and your protons. Full atomic symbol, I'll write a little bit larger here. Remember, we got our mass there for element X. Again, there is no element X, it's just the example. Number of protons, here's your charge, all that good stuff. Okay. This can be helpful if I ever ask you to write the full atomic symbol, but it can also be helpful if you ever see like, oh yeah, phosphorus with like 31. Like, wait, is that the charge? Is that the mass? Is that the atomic number? Oh, wait, it must be the mass because it's in the top left corner. Okay? So it can be helpful for a few reasons to know that little format there. Atoms versus ions versus isotopes. Atoms are neutral. Ions have a charge of some kind. The cat ions are positive, right? Remember all that good stuff? All right, let's talk about how atoms produce light. We've done it several times before. I want you to look up here at me so you can't see it off the sheet. Let's go through the whole process. What part of the atom is even involved in producing light, by the way? Electrons, right? So you have to say the word electrons. Otherwise, I don't know what you're talking about. Okay? Where do those electrons start? Ground state. I love that you said the phrase ground state, but now you have to explain to me what the ground state even is. Closest to the nucleus? Low in energy, right? So like the ground state, electrons start in the ground state, which means they are close to the nucleus and low in energy. Okay? Then we do what to those electrons? You add energy in some fashion. That can be flipping the switch. That can be tossing it in the fire. That can be striking it to see that triboluminescence, all that good stuff. But you add energy in some fashion. When a ground state electron has a bunch of energy shoved into it, it will become excited, which means high energy. Farther from the nucleus. Okay, so that little electron is going to jump up farther from that nucleus when it has higher energy. What goes up must come down. And so that little, what is it again, the part of the atom? It's the electron. Where is it going to go from what to what? Excited to ground, okay? And that extra energy it has that we gave it, it'll release it as a photon. What is a photon? A little packet of light energy, right? And then, reds and violets and greens. Where do we get the different colors, though? Different amounts of energy, okay? So a photon that gives off that red light is a low amount of energy, whereas like a medium one might be green, a higher one might be violet, that kind of thing. Yep. You got to be able to talk to me about that process in your sleep. You got to be able to drop the ground state, the excited state, the photon terms, but also tell me what those mean. Okay. Alrighty. And we also would need to talk to me about, your orbitals, your sp, d, and f. Hey, what are the 3 pieces of information I always need to know about orbitals, by the way? What is an orbital? So electrons used to orbit, but now orbitals are a replacement for orbits. Okay? It's what? It's an area where electrons probably are. Where they probably are. We don't know for sure. So we have 2 pieces of information, 2 of the 3. It's an area or region of space where electrons probably are. And they can hold 0, 1, or 2 electrons. That's right, okay? So again, we used to think that electrons orbit the nucleus like planets orbit the sun on a predictable path, but now we realize, well, actually, electrons are sort of in these orbitals, which are general areas where electrons probably are. There's no predictable path, okay? Just sort of general areas. My orbital would be my room, right? Okay. So my room is a general area where I probably am. I'm not always here. You don't know exactly where I am in my room. I could be at my desk. I could be at the smartboard. I could be at the cabinets. But you know I'm probably in here most of the time. Okay, about 90% of the day, I am, in fact, in room 245. Okay? Not bad, not bad. And then, you want to know about your off-bow versus your Hund's rule. Okay? Off-bow's principle talks about how electrons are always in that lowest energy state. Electrons are kind of lazy, and they want to be at the lowest energy possible. There is a brief exception to that when electrons become excited, right? They violate off-bow's principle briefly, and then they do immediately fall back down, okay, because of off-bow's principle. And Hund's rule, that's the one where electrons don't like each other, and they're not going to double up if they don't have to. So electron 1, 2, and 3 in this situation, like, yeah, we're all separate. And number 4 is like, dang it! It'll double up because it has no choice, but they won't do that until they have no choice. Not bad, not bad. Well, let's go ahead. Let's take a look at our review sheet here. Okay. So here's our review sheet again. Many of you guys grabbed this off Friday. So just some key things again. Remember your A versus your Z. Remember that. Remember your full atomic symbol. Okay, again. Yeah. Remember protons, and then you got the charge over here. That'll be really helpful. And then, know how to find number of protons, neutrons, electrons, all that good stuff. Well, let me see here. Let me show you what handout you guys are actually going to get on the test. Let me show you what you're going to get on the test, because that'll be helpful for this review sheet. This is literally the exact copy that I printed off for you guys in person. Okay, here's what it looks like. The last page of your test tomorrow will just be a periodic table on one side that you can just rip off. Okay, it just says unit test handout at the top. A lot of my students who do well in this test historically, they'll sit down, they'll wait for their test. I hand them the test, they pull off that back page nice and gently so they don't mess up their staple. And then they immediately just like, yep, protons minus electrons equals my charge. And then they're like, protons plus neutrons equals my mass. And they're slapping like a full atomic symbol on there. And whatever else they want to remember. Okay? You can write all over this thing. I don't care what you do to it, okay? Just write all over it. You will be turning it in separately. So when you turn in your test tomorrow, test A, test B, and a pile for your periodic tables. Okay? I'll just be simply recycling them. Nothing on the periodic table will be graded. On the other side of your periodic table tomorrow, so this will be the back of the test that you'll be able to see right when I plop it face down for you. It'll just be some orbital charts, okay? Or you call them bubble charts. At the bottom, I'm super clear. These orbital charts are optional. Use if you want. So some people like to use these to kind of figure out their electron configurations, you know, the little 1s2, 2s2, all that stuff. Nothing on this sheet will be graded. So I'm not going to grade anything on that back page you guys tear off. Okay, it's just there for your use. Some people barely look at their periodic table and their orbital charts. Some people use them constantly. You know, whatever you want, okay? Just nothing on this sheet will be graded at all. It's just there for your use. Are there any questions about that? Okay, great. Well, if we're going back to that review sheet here, so you may have written the full atomic symbol on your periodic table. You may not. You may write protons minus electrons equals charge. You may not. Write what you need, okay? Let me see here. Different things. You know, Aufbau versus Huns. Lots of history there. For the models that you might need to know, I would have at least 4 or 5 models in your pocket, ready to go at a moment's notice. Okay? What do I mean by having the model in your pocket? Well, here's all the information that I would include. Let's say I pick this model right here. Okay? This is Rutherford's model. All right? So drawing that is great. Mr. P is going to need more information than that for you to prove that you know what's going on here. So you would need to kind of have stuff like, okay, that little tiny thing right there, that's the nucleus, Mr. P. And you know what? Just to make sure, really clear, it's positive, it's tiny, you know, maybe something like that. Huh, tiny. And you know, you might want to also include something where you're like, yeah, okay, and the rest of this is just sort of empty. Something like that. Okay, and then you might want to slap a little trademark, Rutherford, whatever. You don't really have to write the TM, I'm just being goofy, but if you want to make it clear to me whose that is. And you know, you would also want to know, hey, he kind of came up with that from his gold foil experiment, that kind of thing. I picked the most complex one, or not the most complex model, but the one with maybe the most piece of information to include, because it's review day, trying to get you as prepped as possible. But yeah, like Dalton's marble model, what are you supposed to do? Just like you draw the ball, be like, that's a marble, signed Dalton. Like there's not a whole lot to include about that, because as we all know, our models become more what over time? More complex, right? Because we're learning more information, okay? And so we're adding that information on every time. And so the model just starts off as like a marble, and then we add stuff to it over time. Absolutely no ground state, excited state. What's the difference between those two? What a photon is. Orbitals versus orbits. You absolutely want to be able to tell me the difference between those two. What they both mean. What we know to be true now. All that good stuff. You got to be able to do bubble charts and then their corresponding electron configurations down here. So again, you know, it's your 1s2, blah, blah, blah. You want to be able to do all that. Now, I've handed you guys a lot of different worksheets today. Not to overwhelm you, and these are not necessarily things I'm going to, well, not necessarily. I'm definitely not going to grade these review sheets, okay? I just gave you as much as I could think of to help you practice. Now, your orbital sheet charts number 2. Again, notice how these are all, we're assuming that they're neutral. When we assume an atom is neutral, we can know what about their protons and electrons. That they're the same, right? Okay, that's not always the case, because sometimes you get ions, blah, blah, blah. But if it's neutral, that will be the case. Now, if you flip to the back page of that, flipping to the back page, I'm going to pretend it's the back page here. Okay, we have a section that's like, okay, so we have our ground state versus excited. It doesn't tell you what element, because you can just pick whatever element you want as your example. So let's say I just pick a really simple element. Let me just say I go with lithium here, okay? Its atomic number is 3. We're assuming its charge is 0, so it also has 3 electrons. And here's what lithium's little guy looks like. 1, 2, and 3. Now, if I want to make it excited, notice what changes and what does not change. It's still lithium. What's the atomic number for all lithiums? 3. Does excited mean it's charged? No, it does not mean that. So it's still got a charge of neutral. So how many electrons does it have? 3. And that's a really big point. It should still have 3 electrons. Now, to make it excited, all you need to do is take at least one of those electrons and throw it up higher than it belongs. So you can take that third electron that was here originally, and you could just have them move up a little north, like boom, right there. Or you can have them take a whole bench and be like, yeah, all the way up there, for all I care, okay? As long as you still have 3 total electrons, and at least one of them has gone up at least 1 layer, we are good to go. You could take the whole family on a trip. Just move all 3 of them up here for all I care. Okay, as long as you have 3 total and at least one of them has gone up at least 1 layer, we are good to go. So that's a good one for you. This one right here. This is probably people's least favorite practice sheet to do because there's lots of history. Personally, if I were 16 right now and I was a high school sophomore, I would have to agree with you. History was always my least favorite. Couldn't stand it. I'd much rather do a bubble chart or do an atomic structure sheet where it's like, all right, 2 protons, 1 electron. Like, I'd much rather do that. Here is a common pitfall, and this is a good life lesson for you guys for any class. Here's a common pitfall for students. And I fell into this all the time up until about junior-ish year of college. It's very, very tempting when reviewing for a test. It's very tempting to practice what you already know. So some of you guys, let's say you're killing it with bubble charts, you're going to be tempted to do that bubble chart worksheet because you're like, all right, I'm going to feel confident, get some ego boost, blah, 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 you're going to dominate it. And it's tempting to not do what you are the worst at because it reminds you you're not so great at it and you have some work to do, and it's not a great feeling, okay? But a lot of you guys, the history might be the weaker section of Unit 4 for you. You should really go to town on this, okay? Go nuts, draw the models, remember the experiments, all that stuff. It'll be a slightly painful process if you don't like history or if it's weaker for you, but not nearly as painful as getting to the test tomorrow and leaving a history question or 2 blank. Now is it, right? Because this isn't for a grade, this is just to help you. This is just to help you. So I strongly encourage you guys to do that. And lastly, let's go ahead and take a look-see at our overall total points and questions. We mentioned this on Friday. Alrighty. So your test is 12 questions and 65 total points. It'll be tomorrow. And we're going to go ahead and look at all the different things that'll be on that test. So, again, element charts. So that's the number of protons, neutrons, electrons, charges, mass. We've seen those on Bellworks like a million times. Like a million times. It's like the chart you've seen. Okay? Always be able to calculate any of those things here. Electron configuration, so again, that's your 1s2, 2s2, 2p6. As long as you know how to do that using a bubble chart, you're fine. Okay, you never have to memorize the bubble chart during Unit 4. Aufbau versus Heinz, orbitals versus orbits. What is the difference between those two? What do they each mean? How are they different? Which one do we believe now? Okay. Bohr and Rutherford, I'm really going to emphasize these guys. These are the 2 heaviest hitters in terms of the atomic history. Absolutely know what they did. Absolutely know what their models are. Absolutely know what they found, okay, and what they changed, all that good stuff. Ground state versus excited. How an atom gives off light. If you don't realize that I'm emphasizing this by now, I think you've been sleepy for like 3 weeks straight, okay, because we've talked about that quite a bit. So make sure you can do that in your sleep. How do electrons move now versus what Bohr thought? How does that change? And again, you'll be using a periodic table, but it'll be a test copy. I already showed that to you. So just make sure you know what you're getting yourself into. Do I have any questions at this time before I let you guys work for a little while on your own? Okie dokie. So I'm just going to come around, check in with you guys. I might make another announcement or 2 towards the end of the period to kind of like emphasize another problem or so. But go ahead and get cooking. You do not have to fill out all of these sheets necessarily, but you do have to work for the entire rest of the period while you're on my time. All right, let's get her cooking.